Question 2.3. A cycling event has 5 riders, 3 from Belgium, 1 from the Netherlands and 1 from Slovenia. All are equally capable of winning. Now, one way of dealing with the questions that come up from such a sort of scenario is just by listing everything out. So here we're going to do, in trying to be as systematic as possible. We can see first place, second place, third place, fourth place, fifth place, and we can see that they have offered 20 different orders. So we'll try and find them, being systematic. So what we can do from BBB NLS is we could just switch the NL and the S, BBB S and NL. Or we could do B, B and then B with NL and S and follow it by B, B and B, S and NL. Then we could do B, B and B in fifth place, NL and S, and we could do B, B and B, S and NL. Or we could do B and then we could move B and B like that, NL and S, B, B and B, S and NL. We could do B, B and B, NL and S, B, B and B, S and NL, B, B and B, NL and S, B, B and B, S and NL. Then the B could go to second place, third and fourth, NL and S, B, B and B, S and NL, B, B and then B, NL and S, B, B and B, S and NL, B, B and B, NL and S, B, B and B, S and NL, and finally B, 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 NL and S, B, 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 S and NL. We have listed all 20. Based on the number of each nationality of cyclist, write an expression using factorial notation to show how the total number of different orders can be obtained. Well, we've got 5 cyclists to choose from, so we're thinking 5 factorial, and if it was 5 nationalities, that would be the answer. However, we have 3 from Belgium. So thinking about the Belgian cyclists, anybody of the three choices for first, then any of the other 2 choices could come second of these Belgians, times by 1, that is 3 times 2 times 1, which is 3 factorial. So our answer, initially it's 5 factorial, but we have to share that by these 6, by these 3 factorial ways with the calculator, 5. Then if we go to toolbox, we happen to be ready with the factorial. If we go across 1, divided by 3, toolbox factorial, and we get 20, which matches the 20 in the list. B. Calculate the probability that the Slovenian cyclist wins. 1, 2, 3, 4. That's it. We have our list. We can just read off the answers 4 ways out of the 20. 4 divided by 20, and we get 0.2. What's the probability that the Slovenian comes in one of the first 3 positions? In other words, first, second, or third. This is 4. We can almost predict what's going to happen. Let's look at second. 1, 2, 3, 4. So that's 4. And then we have 1, 2, 3, 4. There, each position, there are 4 different ways. So that's 12 out of 20. So we have 12 out of 20. And we get 0, 12 out of 20, and we get 0.6. What's the probability that the Dutch cyclist wins? Well, the Dutch cyclist winning, it's going to be the same. 1, 2, 3, 4. The same. The Slovenian, the Dutch, there's just one of those riders. 4 out of 20, 0.2. What's the probability that a Belgian cyclist doesn't win? A Belgian won't win if the Slovenian wins, which is 4 ways, the Dutch one wins, which is 4 ways, so we have 8 out of 20 that the Belgian doesn't win. 8 divided by 20 and we get 0.4. What's the probability that a Belgian cyclist finishes second? One way of doing it is just counting it up, 1, 2, 3, 4, etc. Or we could say, what's the probability of a Slovenian finishing second? So that's going to be 4 ways. A Dutch, 4 ways. So that's 8 where the Belgian doesn't. So therefore 12 ways when a Belgian does. 12 out of 20, 12 divided by 20, 0.6. Last question. Find the probability that the 3 Belgian cyclists finish one directly after the other. So the 3 coming together. So we have there and there, and then we have here and here, and then we have here and here. So we've got 2 and 2 and 2. That is 6 ways. We want a probability 6 ways out of the 20. 6 divided by the 20, and we get 0.3. If we wanted to, we could indicate that it was pathway order number 1, number 2, number 13, number 14, and then number 19 and number 20. Okay.